Namaskar, dear friends and students. Greetings of the day to you all, and welcome to the Learning Management System. This is an initiation of Department of Collegiate and Technical Education. Today's program is Electronics and Communication Engineering for semester 5 of diploma students, and the course is Application of Electronics Engineering, and we are talking on Unit 1 Consumer Electronics. Today's session is third. In the last session we had seen the definition of consumer electronics, and thereafter elaborately we had seen how a calculator works, what are all the PCBs and ICs are incorporated in the calculator, and now we are moving to our kitchen, right? So nowadays in the modern kitchens we are using a gadget. As you might have seen, this is a microwave oven. So what is a microwave oven, or why it is called a microwave oven? Right, a microwave oven is an electric appliance, and it's an alternative form of cooking, also called as microwave or just micro. This type of oven uses electromagnetic wave technology to cook food. Wow, that's great. Electromagnetic waves for cooking? Certainly. Now we'll see how it cooks, the principle of microwave cooking, the block diagram of the microwave, and the advantages of microwave and the applications. Everything we are going to see in this session. So let's start. So in every era has contributed its own ideas and conveniences to the kitchen, from open stove to the closed one, from wood to oil, coal, electricity, gas, and now the age of microwave oven. Microwave ovens considered as a luxury for long time because they were very costly, and uh, the earlier microwave ovens, they used to weigh in in, in almost in tons, and the heights used to be some more than 1.5 meters or something, but mostly they were used in restaurants and big factories and all. And very recently it has come to our kitchen thanks to the magnetron, which was developed in a very small size, and all the safeties are taken and they are in place. So, but as the pace of modern lifestyle has got faster and busier by the day, microwave oven cooking has proved extremely helpful in the efficient preparation of food in the shortest possible time. Almost every MNC is having a microwave for their staff's food heating in their kitchen or in their dining area, right? And as you have seen how a microwave oven looks like, this is one type of almost all the microwaves which are being used in kitchen. They look like this. Now moving on to the principle of microwave cooking. What is the principle exactly? How the food is cooked with the help of just electromagnetic waves. The microwave oven uses microwave frequencies of 2.4 gigahertz to cook food. Microwave ovens have a main heart in the top flooring that is called magnetron, specially designed to make use of energy in microwaves. Electricity applied to the magnetron tube is used to create microwave energy. Rapid microwave cooking provides excellent quality of food. The cooking in microwave actually the cooked food is excellent. This quick method of cooking using a minimum quantity of water helps retain most of the nutrients. In addition, microwave preserves natural flavors while enhancing the color and texture of the food. But how it is done, right? Microwaves are non-ionizing, high frequency, short wavelength electromagnetic waves. Microwaves are attracted by the moisture in the food placed within the oven for cooking. The microwave then penetrates the food surface, causing the moisture molecules to vibrate. This is the principle, causing the moisture molecules to vibrate. Certainly, vibration causes friction, and friction generates heat. Just you can try like this. If I rub my hands very slowly or vigorously, some heat is generated. But this is just, I am saying, say 10 hertz. But if I do this at 2.4 gigahertz, think of it. So the water molecules are having H2O. So when the electromagnetic wave when it falls on the molecules start vibrating. This vibration generates heat, which then cooks the food by conduction, right? The food is cooked from the outer surface and then to the inner core, right? So the principle is the movement of water molecules due to microwaves and at a very rapid speed or rapid frequency, right? Moving on to the next, what are the advantages of microwaves? See, heating through microwaves has the following advantages over conventional electrical heating systems. Quicker heating saves time, certainly. The heating is very fast, so it saves time. The system is very clean because there is no spilling and all. So the system remains very clean. Preserves the natural flavors. So almost the natural flavors are preserved by this cooking. Retains most of the nutrients. As you all know, we take food to have nutrients. So certainly the nutrients must be retained. Enhances the color and texture of food. The color and texture becomes more attractive. System can be combined with a conventional heating process. It can be combined with conventional heating process, as we are seeing nowadays. Preheating or post heating is all done with the help of the ovens, this microwave ovens. Now, how a microwave oven turn electricity into heat? See, inside the strong metal box there is a microwave generator, so which is called magnetron. It is a very small piece of an electronic item. The magnetron blasts these waves into the food compartment through a channel called waveguide. The microwaves which are generated are passed through a waveguide, which then they bombarded into the compartment of the oven, microwave oven. The food is kept on a turntable which keeps on spinning slowly so that the microwave cook it evenly. The waves should reach to every molecule evenly, so the food is cooked evenly. The microwaves bounce back and forth off the reflective metal walls of the food compartment. So due to this reflections, almost each microwave, it is not coming out of the box or microwave oven, so it again it is reflected back to the food or inside the compartment. Now let us see the block diagram of a microwave oven. It's very simple, looking very simple. As you can see here, conventional method of heating, heat is transferred to the surface of the material to be heated by conduction, convection or radiation, and into the interior mainly by thermal conduction. In contrast, in this microwave heating or dielectric heating or any other frequency, heat is generated directly inside the material. Heat is not generated outside, but directly inside the material the heat is generated. Therefore, it is possible to obtain a much faster temperature rise than conventional heating. As you can see, the figure here shows the block diagram of the microwave oven. The AC mains plug and sockets are, you can see here, 230 volts at 50 Hertz AC is applied. It's a 3-pin socket, and certainly we need to have earthing. Earthing is very, very important. 3-pin earthing is there. The fast blow ceramic fuse of 15 amps, as you can see here, at 250 volts, and then you can see the interlock switches are linked with the oven door. Power will be applied to the mains transformer only when the oven door is closed. This is for the safety of the human being or the man who is using this oven. An interlock switch in series with the transformer primary. Hence, even a spot of dirt in the relay can't turn the oven on when the door is open. Another interlock switch across the power supply line, it normally remains open. If the door alignment is not correct, certainly we have to keep the oven in a flat surface. It should not be kept horizontal or in a tilting way. It should be kept on a very flat surface. If the door alignment is not correct, it will be activated, putting short circuit across the line and making the fuse to melt. Certainly, if the door is not aligned, it will not close properly and some of the electromagnetic waves will leak out of the box, causing the damage to or injury to the man standing near the oven. So that's why this shunt interlock is there. Thus, microwave oven is safe. The voltage induced in the secondary winding is about 2000 volts RMS at 250 milliamps for normal domestic ovens. The transformer also has winding. Here you can see winding for magnetron filament. The high voltage return circuit is fastened directly to the chassis ground. A half wave doubler configuration is used for the rectifier. With the peak inverse voltage of about 12,000 volt. One end of the diode is connected to earthing, as you can see here. The diode's other end is connected to the earth. The bleeder capacitor the bleeder capacitor should always be discharged before touching anything inside when the cover is removed. So one thing is for sure, you should not be opening your microwave oven in your home. You should call the experts, because this capacitor, when it is charged, it is harmful. So we need to discharge it first before touching anything inside. When the cover is removed, this is only for the purpose of the technicians, not for the home use. The high value bleeder resistor is slow to discharge. And then, as you can see, there is a thermal protection or thermistor. It is a positive temperature coefficient thermistor. The primary current decreases when the temperature rises abnormally. It senses the temperature of the magnetron as it is bolted to the magnetron case and is so connected electrically that its resistance comes in series with the primary circuit. So if the heat increases beyond, so this will protect and this will stop the current to flow, right? So the controller is a microprocessor chip. You can see here microprocessor chip with a clock. Certainly it has got a clock inside. It is activated by keypad switches. You can see many of the keys outside the box, right side to the panel, the door opening. So the clock can be activated by keypad switches, and there are so many timers and how much time it should take, how much fast it should spin. So the sleep time, so many things are there. So cooking the switches and sets the cooking time. It senses the temperature and moisture, sets the power levels and runs the display. There is a LCD display is also there, in which you can see how much time we are switching on the microwave oven. After the stop, it will show the timing also in the display, and even there is a buzzer, some of the microwave ovens. There are three power levels. For high, the microgenerator magnetron remains on continuously. For medium, it remains on for 10 seconds and off for 10 seconds. For low, it remains on for 5 seconds and off for 15 seconds. This timing is controlled by the microprocessor. So, the controller activates the microwave generator using either a relay or a triac. So, we have seen how a microwave oven produces the EM waves and how it is controlled in this block diagram. Now, moving on to the next, that is microwave oven types. Certainly, a good oven should assure conversion of the delivered microwave energy into thermal energy in most effective manner. Various possible configurations for ovens may be divided into two groups. One is multi-mode cavity type oven and the second is open slow wave structure type. So only you have to remember these two types, that is multi-mode open cavity and the second is open slow wave type. And now we are moving to the applications of microwave oven. Certainly now you might ask, other than cooking food, where it can be applied? See, processing and cooking of food products is the major application of dielectric heating at microwave frequencies. It is a major. Certainly we all know it is used for cooking the food. And then microwave oven have taken almost all households and bulk cooking. They are used in restaurants, hotels, bakeries. Nowadays every bakery is having this microwave oven for preheating the products or even post heating, right? So baking cakes, breads, defrosting means removing the ice particles, grilling, roasting, etc. Everything is done in the microwave oven. And then medical applications, diathermy. Some of the cancer treatments are given with the help of this microwaves. It is called radiotherapy, also called as radiotherapy. The microwaves, since as we all know, it is having the capacity to kill the cells, so the cancerous cells are killed with the help of pointing these microwaves to the cancerous cells. Sealing of plastics. The plastics can be sealed easily with the help of microwaves. They also are used for destruction of dry, rot, fungus and wood worms in timber. When the worms are there in the timber, the microwaves are used to kill those worms with the help of microwaves. Curing and breaking of concrete. The concrete is cured as well as it can be broken. You can refer these books, Shri S.P. Bali, Consumer Electronics, Pearson Publishers, and T.J. Katewal sir and M.N. Java Cursors Application of Electronics Engineering for 5th semester diploma in electronics and communication. In the next session, we are going to see how a washing machine works. Right? Thank you. Thank you, one and all. You can write to us at lms.dtek@gmail.com. For any help, you can write to this mail, and certainly after this 10 MCQs will follow only on this session. Try to answer those. Thank you. Thank you so much.